Classification is a fundamental aspect of science. Chemists study chemicals, and chemicals make up matter. Matter is anything that has volume or takes up space and has mass. Although matter is related to everything in our everyday life, not everything is matter. Take a minute to see if you can think of something that is not matter. Air, by the way, is matter. If you came up with examples such as thoughts, ideas, or feelings, you are correct. These are not matter, even though all of these are transmitted through neurons, which are made of matter. If you came up with any type of energy, such as light, sound, or heat, you are correct as well. We already have dozens of systems of classification of matter in our everyday life, which depend on specific contexts. Food, furniture, cells, and all their subclassifications are familiar ways that we classify matter. However, chemists have a different context of considering matter, and therefore have defined different classifications. There are also dozens of ways that chemicals can be classified in chemistry, but we will start by thinking about some of the most fundamental categories. The state of matter, solid, liquid, or gas, is one fundamental category that we will discuss later. The classification of matter as a pure substance or a mixture is very useful to chemists. Pure substances are chemicals that have a constant composition, and therefore they have constant properties, such as color, melting point, or state at room temperature. There are two types of pure substances. Elements are one type of pure substance. Elements are always found on the periodic table and have a unique symbol, which only has one capital letter. You can see this by viewing a periodic table, which always has the elemental symbols. Compounds are the other type of pure substance. Compounds are made of two or more different elements that are chemically bonded, sort of glued to one another in specific unchanging ratios. Compounds have chemical formulas that let you know how many atoms of a given element are in a molecule. C6H12O6 is the chemical formula for glucose. A molecule of glucose always has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Once atoms chemically bond to one another, their properties change. Properties of compounds are not related to the properties of the elements that comprise them. Let's look at the compound copper 2 chloride, which is made of copper and chlorine. As an element, copper is a metallic solid at room temperature. It has an orange-brown color, does not dissolve in water, and is an excellent electrical conductor. As an element, chlorine is a yellow-green gas, which is highly toxic. Copper 2 chloride, which is made up of both these elements, is a grainy, light blue solid that dissolves in water. Its properties are completely different from those of the elements that made it up. Before we go any further, let's talk about atoms for a minute. We will address atoms in more detail later, but it's useful to say that atoms make up matter. We use spheres to represent atoms in models, and some elements have their own color. In this model of the molecule acetic acid, or C2H4O2, we see that carbon is black, oxygen is red, and hydrogen is white. Atoms of the elements carbon, hydrogen, and oxygen show up in thousands of chemicals. The two models on this slide are examples of a ball and stick model, which shows the atoms as spheres and the bonds that keep them together as lines or sticks, and the space-filling model, which more accurately represents the space occupied by electrons in molecules. Let's stop and think about what we have covered so far regarding pure substances. Pause this video and identify each of these pure substances as either an element or a compound. Sodium chloride, NaCl, water, H2O, oxygen, O2, iron, Fe, glucose, C6H12O6. Now let's look at the answers and see how you did. Sodium chloride, NaCl, is made up of two elements, sodium and chlorine, in a 1-to-1 ratio. Thus it is a compound. Water, H2O, is made up of two elements, two hydrogen atoms and one oxygen atom, so it is a compound. Oxygen, O2, only has one element, so it's an element. Iron, Fe, is an element. And a molecule of glucose is made of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Glucose is a compound.